Hi, in this video, you will understand the types of electronic transition for a molecule that absorbs electromagnetic radiation in UV and visible region. You will also understand the effect of chromophore groups in the molecular structure of absorbing species on mode of electronic transition. Electrons in a molecule can be classified into 4 different types. Closed shell electrons that are not involved in bonding, covalent single bond electrons or sigma electrons, paired non-bonding outer shell electrons or N electrons, and double or triple bonds electrons or pi electrons. UV and visible radiation interact with matter, which causes electronic transition or promotion of electrons from the ground state to a high energy state. The UV region falls in the range between 200 to 380 nanometer, while the visible region falls between 380 to 750 nanometer. There are 4 types of possible electronic transitions for sigma, pi, and N electrons as shown in this energy level diagram. Sigma to sigma star, pi to pi star, N to sigma star, and N to pi star. The length of the arrow is roughly proportional to the energy difference between 2 levels. The longer arrow means a higher energy transition. Thus, sigma to sigma star transition has the highest energy transition, while N to pi star transition has the lowest energy transition compared to other mode of electronic transitions. The energy difference values for all the possible transitions are in the order sigma to sigma star, N to sigma star, pi to pi star, N to pi star. Sigma to sigma star transition. An electron in a bonding sigma orbital is excited to the corresponding anti-bonding orbital. This transition involves saturated hydrocarbons with strongly bonded sigma electrons. The energy required is large. Absorption maxima due to sigma to sigma star transitions are not seen in typical UV and visible spectra in the range of 200 to 700 nanometer. For example, methane, which has only CH bonds, can only undergo sigma to sigma star transitions, shows an absorbance maximum at 125 nanometer. N to sigma star transition. Saturated compounds containing atoms with non-bonding electrons such as oxygen, sulfur, nitrogen, and halogens are capable of N to sigma star transitions. These transitions usually need less energy than sigma to sigma star transitions. They can be initiated by light whose wavelength in the range of 150 to 250 nanometer, and the absorption is not very intense. The number of organic functional groups with N to sigma star peaks in the UV region is small. For example, methylamine undergoes N to sigma star transition at 170 nanometer due to the presence of non-bonding electrons in nitrogen atom in its structure. Pi to pi star transition. Compounds containing multiple bonds like alkenes, alkynes, carbonyl, nitriles, and aromatic compounds undergo this transition. Absorption maximum for this transition occurs in the range of 160 to 190 nanometer. For example, ethylene undergoes pi to pi star transition at 171 nanometer due to the presence of double bond in its structure. N to pi star transition. Compounds containing double bond involving heteroatoms undergo such transitions from non-bonding orbital to antibonding pi star orbital. N to pi star transitions require minimum energy and show absorption at longer wavelength around 300 nanometer. For example, acetone undergoes N to pi star transition at 274 nanometer due to the presence of carbonyl groups in its structure. Most absorption spectroscopy of organic compounds is based on transitions of N or pi electrons to the pi star excited state. This is due to the absorption peaks for these transitions fall in an experimentally convenient region of the spectrum at 200 to 700 nanometer. These transitions need an unsaturated group in the molecule to provide the pi electrons. That's all for this video. Thanks for watching.